So this is a video on brain scans. Remember, there's three different types of brain scans that we look at in psychology. Positron emission tomography, or PET scans, functional magnetic resonance imaging, or fMRI scans, and CAT scans, which stands for computer axial tomography. So there are three different types of scan. The first one is positron emission tomography. In a PET scan, what we do, remember, is we inject people with a radioactive chemical. This is kind of glucose, so the fuel that your brain uses, the sugar that your brain uses for fuel, is irradiated and it's injected into the person. This is called FDG, fluorodeoxyglucose. And the purpose of this is to see kind of activity in the brain. So we inject you with this radioactive glucose and your brain uses it for fuel. So the areas of the brain that are more active will use up more of this fuel and they'll go bright colours like red and orange, whereas the less active areas of the brain will be blues, greens, dark purples and things like that. So high activity reds and orange, low activity blues and greens, and this lets us see what areas of the brain are being particularly active. So if we inject you with this and then give you, say, a maths task, we are able to figure out what parts of the brain are responsible for things like maths. So remember, we use this to look at the activity of the brain. These are some of the strengths and weaknesses of PET scans. So we can look at receptor sites of neurotransmitters, which fMRIs, which we're going to get into in a moment, can't. PET scans are reliable, they are applicable, they are objective, they are scientific. Remember, it's objective because we are measuring a solid object. We are measuring something that really exists. Rather than trying to kind of measure a personality construct or anything like that, we are measuring an actual physical thing. Weaknesses, it's obviously invasive and possibly harmful because we're injecting you with a radioactive tracer. It's hard to pinpoint exact areas of the brain with a PET scan, so there's going to be kind of a problem with being kind of that precise. Other areas of the brain might light up because they're also in use at the same period of time. One thing that we can argue it's either a strength or a weakness is, one, they are relatively non-invasive. That should be invasive rather than evasive, compared with surgery. So before we had scans, we had to basically cut open people's heads to have a look at their brains. So it's relatively kind of non-invasive compared to that. However, it is still in itself invasive. The next one is functional magnetic resonance imaging, or fMRIs. An fMRI uses magnetic radio waves to scan the brain. So the person would lie in a large cylinder in which they have to lie perfectly still and not move. And what we do is use magnetics and radio waves which are bombarded through the body to look at the blood flow. So remember, blood carries iron in hemoglobin, and we are able to see kind of how that moves based on how it kind of interacts with that magnetic field. So if it is kind of very low in oxygen, if the hemoglobin has given away all of its oxygen, so it's being used in an area of the brain, it will move one way. If it is full of oxygen and iron and things like that, it will move another way. So we're able to see what parts of the brain have been using oxygen based on how the blood flow moves. And that kind of explains that. So hemoglobin, when it's full of oxygen, repels the magnetic field and moves against it. When it's deoxygenated, it moves along with the electric field. So again, strengths and weaknesses: scientific, objective, reliable, very precise. It measures blood flow of the brain. And some of the weaknesses: it can be very hard to measure neurotransmitters, unlike PET scans. Certain people can't use fMRIs, such as people with pacemakers. It can affect the blood flow in the brain, so that's a negative, and so on. And then finally, we've got CAT scans, computerized axial tomography. CAT scans involve a focused X-ray being fired into the brain in kind of slices. Remember, X-rays are only 2D, so what we have to do is use 2D X-rays, but we do it in kind of slices, and that's that axial because it means at angles, and we build up a 3D picture of the brain using that. And with that, we're able to build up a structural view of the brain, what the brain looks like. Kind of particularly, we're looking for areas that are damaged or areas which have suffered kind of trauma. Particularly, we might look at things like tumours. Again, here are the strengths and weaknesses of this. Again, lots of the same things: scientific, replicable, reliable, and we can use it to help surgeons figure out what's going on in the brain before we start surgery. It's non-invasive, but there are kind of the similar weaknesses. And we are dosing you with some radiation, no more than a normal X-ray, but still it's something to consider. It's not as helpful as an MRI scan when looking for things like infections. And the image is easily distorted by kind of head movements and things. That's why you have to remain incredibly still. So that's a quick summary of the 3 types of brain scan.